So let's begin with the lesson. Welcome to you, everybody, and welcome to you in this cryptocurrency trading course. This course is brought to you by the United Africa Blockchain Association, UEBA, in conjunction with FTX. Before I start, I would like to share with you the vision and mission of UEBA. So UEBA, United Africa Blockchain Association, is a non-profit organization formed for the promotion of the adoption of blockchain technology and creating partnerships and networks that deliver on life-changing blockchain projects. Our learning programs empower individuals and organizations with skills and networks to build solutions that take advantage of blockchain technology. The mission of UEBA is to unify the African blockchain ecosystem towards 8 goals of harmonious coexistence and progress, which are education, financial inclusion, sovereign identity, skills development, job creation, gender equality, and efficient trade and poverty alleviation. So in this lesson or in this session, we will learn about blockchain. We'll see the brief history of blockchain. We'll check out the structure of a blockchain, the workings of a blockchain, and that. Then we wrap up with the use cases of blockchain. So Bitcoin and blockchain, or must I say cryptocurrency and blockchain, are super connected. To talk about one requires the mention of the other. But how is blockchain technology distinct from cryptocurrency? And as you know, cryptocurrency is an application of blockchain, right? So to understand the broader implications and applications of blockchain technology, we'll have to split the two so that it can help us understand why there is so much excitement about blockchain and why there is so much excitement about blockchain-inspired disruption. So what is blockchain? To start with, I want you to view blockchain as an internet-based infrastructure upon which applications can be built. So just like the early internet was to static read-only websites, or just like the social media platforms are today for user-based content, that is what blockchain is to decentralized applications such as cryptocurrency, decentralized apps, DApps, NFTs, and DeFi. Now that is settled, let's get into the textbook definition of blockchain. So the textbook definition of blockchain. Don't mind me, right? My head will be turning this way and this way, right? Because I need to let people in, right? So yeah, let's look at the textbook definition of blockchain. What is blockchain? Blockchain is a growing list of records called blocks that store data publicly in a chronological order. The information is encrypted using cryptography to ensure that the privacy of the user is not compromised and the data cannot be altered. So information on a blockchain network is not controlled by a centralized authority, unlike the way it is in the modern financial institutions. The participants of the network maintain the data and they hold the democratic authority to approve any transaction which can happen on a blockchain network. So therefore, a typical blockchain is a public blockchain. And as long as you have access to the network, you have access to that blockchain. If you are a participant on the blockchain network, you will have the same copy of the ledger which all other participants have. So even if one node or data on a particular participant's computer gets corrupted, the other participants will immediately, or the other participants have that data, right? And consequently, that will be rectified, or at least the machines that break down, or a machine that has got corrupt data, won't be the machine that others will look to. So that is one of the fault tolerance systems that has been etched into blockchain. So now let's look at the technological stages and milestones which benefited blockchain technology. The first one starts in 1982 with a cryptographer named David Chaum, posed a blockchain-like protocol in his 1982 dissertation entitled Computer Systems Established, Maintained, and Trusted by Mutually Suspicious Groups. Then come into 1991, we have Stewart Haber and W. Scott Sonata, who further developed ways on cryptographically securing a chain of blocks. They wanted to use it for a system where document timestamps tampered with. Following 1 year later, that was in 1992, Haber, Sonata, and David Bayer added Meko trees to the design. This made it possible to have several document certificates to be collected into one block. Under their company, Surety, these document certificate hashes have been published in the New York Times every week since 1995. So even up to now, this thing is still going on, I guess. That's what I call a blockchain on a newspaper. So you can see some of the technology that have benefited blockchain that happened as early as the 80s, right? So yeah, move into 2008. In 2008, the first decentralized blockchain, as we know it today, was conceptualized by a person or a group of people known as Satoshi Nakamoto. So Nakamoto used a hashcash-like method to design a way to timestamp blocks without requiring them to be signed by a trusted party, and a difficulty parameter to stabilize the rate at which blocks could be added. Right. So enter 2009, sorry. Enter 2009. Nakamoto used his design as a core component in the implementation of the first cryptocurrency Bitcoin, where it serves as a public ledger for all transactions on that network. So you can see that Bitcoin borrowed a lot from the other technologies in cryptography and all that. The one that I mentioned, the hashcash, is also borrowed from the guys that used it in emails, so that they could deter, delivery of service attacks and. So yeah, let's move on. Now, let's look at the structure of the blockchain and the inner workings of the blockchain. A blockchain can be seen as having the following layers: the node application, the ledger, the consensus algorithm, the blockchain network or networking, and the applications layer. So now let's begin with the node application. A node is simply a computer So let's say if a node wants to take part on a Bitcoin blockchain, it will need to run a software application specific for Bitcoin blockchain. A node is barely a computer that is participating on that blockchain. So if the node wants to participate as a full node, and not this when I say full node, right? So if it wants to participate as a full node, it will need to install a full client application for that blockchain. So what I mean in this sense is that, so if you want to run a full node, right, you will need the software that gives you an opportunity to download the whole blockchain and everything that is required that goes with it, right? So you are talking about the consensus algorithm and that, so that when you do that, then you are part of the consensus making process. So you and your blockchain that you have downloaded on your node, you are able to participate that way. So the other way, if a node is a light node for the purpose of, let's say, just having a Bitcoin address where you send and receive Bitcoin, a light node application such as a wallet will be needed to be installed. So yeah, that is that about node applications, and that is where you begin from. So you select how you, so depending on how you are interacting with that blockchain, so you select your application that way, right? So up next is the digital ledger, or the ledger, what most of us call the blockchain, right? This is synonymous with the term blockchain itself. So the digital ledger is the data structure of blocks managed inside the node application. Once you have the node application running, you can view the respective ledger contents of that blockchain. So now, let's take a bit of time to look at the inner workings of a ledger and the blocks, right? So blocks hold batches of valid transactions that are hashed and encoded into a Merkle tree. Each block includes the cryptographic hash of the prior block in the blockchain, linking the two together, as you can see on the diagram there, right? The linked blocks form a chain. So that is where that name comes from. So a block connecting to the next block in a chain, right? This iterative process confirms that the integrity of the previous block all the way back to the initial block, which is known as the Genesis block, is maintained. To assure the integrity, right? To assure the integrity of a block and the data contained in it, the block is usually digitally signed. So let's look at the anatomy or the structure of a block. So a block has a previous hash. It has transaction data presented in a Merkle tree, right? It has what is known as a nonce. Then it has a hash address, right? So the previous hash obviously belongs to the other block, right? Then the transaction data, that's the information of transactions, several transactions that have been encoded in a Merkle tree in that block. Then the nonce is a random figure that acts as a variate for that hash. Then you've got the hash address for that particular block. That is a unique identification of that block. It is usually a hash, or is it a hex? Yeah, that's what they call it. A hex figure of 64 characters, a combination of letters and numbers contained in an algorithm, a SHA-256 algorithm, right? So that is the cryptography encoding that that is used, the SHA-256 algorithm. So that's that about how a block looks like, if you are interested in how a block looks like. And all this will matter as we move forward and you see how everything works. So now let's look at the consensus algorithm. The next, the consensus algorithm, just a short pause. Make sure that if there's any questions, you drop your questions in the chat area, right? Then I will attend to them at the end of this teaching. So now let's continue with the consensus algorithm. The consensus algorithm is implemented also in the node application, it provides the rules of the game of how the blockchain will arrive at a single view of the ledger. So what will happen sometimes, especially when it comes to the consensus algorithm and the machines as they take part in deciding which one is the single view of the ledger, sometimes separate blocks can be produced concurrently and you have a temporary fork. So a fork will be a situation where some nodes follow a certain chain, others also follow a certain chain, right? Apart from having a secure hashed history, that is that same line which shows previous node to this node and that node, a blockchain has a specific algorithm for scoring different versions of the history so that one with the highest score can be selected among the others. So for example, Bitcoin uses the proof of work system where the chain with the most accumulated is considered the valid one by the network. And apart from proof of work, one of the other popular consensus algorithm is the proof of stake. So let us look at the proof of work algorithm. So the proof of work algorithm is a form of cryptographic proof in which one party, who is the prover in this case, proves to others who are verifiers that a certain amount of specific computational effort has been expended. So the verifiers can subsequently confirm that the expenditure can confirm that expenditure with a minimum effort on their part. But while the other side, right, the one who is doing the proving has to use a considerable amount of computational power. So if I can pause here to just explain something, if you can see here, the way it was used earlier on in email, right? So in case you've got a user who is just continuously sending data to an email or a website, right? They would make a website crash, isn't it? So what they did, they produced this, the proof of work, in which for a computer to be able to send mail to the other to the server, isn't it? It had to prove work. So that work meant a considerable amount of computational power. Or in this case, you have to pay for it to be able to use or to be able to send that type of mail. So in that way, it helps what is known as DOS attacks. And also here, we see that the blockchain implements this, but it implements it in this way that Bitcoin, right, the provers or the miners compete for a block, meaning that they have to find the nonce. Now, if I go back to that structure of the block, the anatomy of a block, there is a nonce value there, right? So the provers or the miners on Bitcoin need to compete for what? For a block, and they have to find the nonce figure for that block by solving mathematical computations. So that is the computational power that they have to provide as they solve that. So once a miner discovers a nonce figure, he or she spreads the word throughout the network, and if the other miners or verifiers verify that and find it as a valid claim, then the miner adds the chain and also the miner is rewarded, right? So that is where the incentive enters in for the machines that are maintaining the network. So the machines that are maintaining the network, they get rewarded for that. So that whole process is called what? It's called mining. So mining is the process of a miner being rewarded for finding the appropriate nodes as the first. So the first one that finds the nonce figure, they are rewarded for that, and they get to add that block to the chain. So miners get paid in Bitcoin. If we're looking at the Bitcoin blockchain, or in Ethereum, they get paid in Ether. And a successful verification is the way that Bitcoin is added to the network. Is the way that mining is the way that Bitcoin is minted. So mining is the only way new Bitcoin can be generated, and it also ensures that there is a limit to how many Bitcoin can exist in the market. So on the Bitcoin blockchain, currently the miner's fee, the reward for finding a block, is 6.25 Bitcoin. That is given for adding a block. So one miner wins the block reward roughly every 10 minutes. So 10 minutes is the Bitcoin cycle. So depending on which blockchain you are on, that cycle is Bitcoin has got 10. I think Ethereum something within just minutes. Some have like I think Solana is really like super quick. That happens in milliseconds. It's that fast. So you can understand that when it comes to Bitcoin, there's always that lag in between before transactions show. So there's that 10-minute gap, that 10-minute period in which consensus takes place. And once it takes place, then information is given. So all those nodes, they refresh their blocks, and they are able to broadcast the data. So to recap, the consensus algorithm sets the rules on how blocks can be added to the chain, when blocks are considered valid, and how conflicts of truth are resolved, what kind of functions each category of nodes will have, and also when new units of the digital asset are minted. The next layer is the blockchain network. So amongst all these layers, right, the others are logical layers, right? So they are like more software, more, logical. So this is the hardware part of the network. So a blockchain network consists of machines. Let's say the Bitcoin network consists of machines that are running the Bitcoin software in various or several distinct configurations. So a typical blockchain network will have the following category of nodes. The first is the full nodes. So full nodes contain an entire copy. And remember, when I speak about nodes, nodes are basically computers, right? So they could be, as I showed you here, they could be this, this is a mining rig here, right? So this could be a node, right? This could be a node, a laptop could be a node, a cell phone, provided it is able to hook up and do the work that you want, could be a node. So each time that you have let's say your phone, right? You have your phone, like on my phone right now, I have, let's say I pick out, I take FTX, right? It has got a wallet, so it will be able to connect me to the network. So I'll be like, so full nodes are basically nodes that contain an entire copy of the blockchain in real time. They download every block transactions that has ever happened on the network since the Genesis block, not just the most recent ones. As long as the full blockchain exists on at least one node, there will be a record of all Bitcoin and Bitcoin transactions throughout. In addition, a proof of stake network, on a proof of stake network, right, you will find that the nodes can be divided between validator nodes and intermediary nodes. So you'll find that on blockchain, let's say like Celo, which uses a proof of stake algorithm, you'll find that there are 3 layers of nodes like this picture shows here. You find validator nodes, full nodes, and light nodes, right? So the last category of nodes is the light nodes. Light nodes are nodes which typically only download the most recent blockchain data needed to process and verify transactions. This minimal approach keeps light nodes running quickly and efficiently without requiring too much computational power or storage resources. So you'll find that most of us, that's the way we connect to the blockchain. We have either a wallet, right? We have either a wallet, and we're just checking out what kind, our data on our transactions and all that. Then you get the most recent data. Yeah. So now let's look at the last layer, which is the virtual machine or the applications layer. The virtual machine is the final component implemented as part of a blockchain, or should I say a node application, that participates on any blockchain. So every blockchain, it doesn't matter what kind of a blockchain, has got a virtual machine, right? What differentiates the virtual machines is the amount of computation or programmability that it has, right? So let's take, for instance, the Ethereum, which pioneered the development of the Ethereum virtual machine to create programmable computers distributed over across a number of nodes. The virtual machine on the Ethereum understands a wider range of instructions, making it possible to manage the state of smart contracts. So this is where smart contracts come in. So the instructions on the virtual machine takes the form of special programming language that instructs the EVM in the node application to enforce the terms of the contract. So once that is done, then the contract, you pay for that, then the transaction is made, satisfied, and you go ahead. So these same smart contracts are the building blocks of decentralized applications. Or must I say, these same smart contracts are what are used to create applications on a blockchain like Ethereum, or on a blockchain like Solana, a blockchain or like Celo, right? Ethereum being the first to develop such kind of a layer on top of a blockchain, right? So that gives users an ability to be able to create other tokens, just like the way Ethereum has been able to give rise to other tokens. So apart from the actual native coin that is there, Ether, right? Others using the smart contracts are able to create tokens. They're able to create, apps, like apps in loans, decentralized financing, apps that do all sorts of things. I mean, you just have to apply your mind and make an app. So what do the apps translate to? The apps translate to businesses. So you are able to literally create, an app which is scalable, an app or a business which is scalable on the blockchain. So that is what the virtual machine entails, or what the virtual machine is all about. So those are the main layers of a blockchain. Typically, any blockchain has got these layers that I have mentioned. And because of these layers, you'll find that it is these things that show you what kind of work a blockchain does. So let's look at the used cases, some of the used cases. So some of the use cases, first and foremost, cryptocurrency. So use cases basically are applications, how the blockchain has been used. So the first one is cryptocurrency. Like I said, you get smart contracts, you get financial services. And financial services, both on the blockchain, financial services, like I said, decentralized finance, all sorts of other decentralized applications or DApps that have been created to do, like most of the work has been financial work that is coming out of the blockchain. So you get a lot of financial work that is coming out of the blockchain that has been done. So you also get traditional financial services that have really taken up the blockchain because of things like being able to do peer-to-peer transfers between banks. Clearing settlements are much easier to do, and much cheaper to do using blockchains. So, over the years, we find that there is a number of banks that have adopted blockchain. We know that JP Morgan here in South Africa, we know that Standard Bank have got their own blockchain, and they are seeing value, they are seeing costs go down, and also transactions are able to happen quicker. So where we are, I think adoption has gone very far, especially in the financial world. Already a communique went out, I think 2 or 3 years ago, from the IMF that central banks need to consider creating their own digital currencies as part of the implementation going forward. So those are some of the things that are on the ground. So other things are in the entertainment industry. We know the entertainment industry, right now there's a buzz in the entertainment industry, and that buzz is NFTs, So those are some of the applications of blockchain, right? So in the entertainment industry, we know that especially in gaming uses NFTs for monetization. It uses tokens for in-game purchases and all that. And there's the new thing that is a craze right now that is on the lips of most of the geeks and tech people out there is the metaverse. So there are metaverses that are created on the blockchain that are taking off, and they are gaining traction, like Decentralized Land and others I don't know. I think you've got gaming platforms like, is it Axiv or something like that? I think I'm pronouncing it wrongly, yeah. So you get a good number of use cases that have become pronounced now, because we are no longer just in concept, but the concepts have been put to work, proof of work, and they've shown that they can do. So basically, this is blockchain 101. Yeah, thank you so much. Yeah, there's Axie, Infinity, what, yeah. So this is what I had for you for today. I fought for you guys who hadn't done blockchain, introduction to blockchain. So this is what I had for you today. Tomorrow we'll look at cryptocurrencies, and we'll look at cryptocurrencies and I guess cryptocurrency ramps, because they're important to the course that you are doing. You need to run ramps and your cryptocurrencies so that you as one of the first steps of trading. So right now I'll open up the